Okay, this is apparently the last question. Um, so I just checked, this paper's only 40 marks and it's for an hour. The other papers after this, I think are almost an hour and a half, and it's 50 marks. Okay, so an extra 25% on on this one. So I don't know if I've not done the calculator yet. Let's have a look. I think the calculator's bigger than. That's 50. I'm sure it's 50 and 50 for the other one. Maybe it's just around the other way. Possibly, I'm not sure. But I just thought this paper was going to go on a bit longer. Because usually it's been 15 questions. I think I can number. So yeah, okay. Last question. And again, the questions should really get harder and harder and harder. Well, not really, but that's what I found. They throw a few more tricky ones towards the end. And actually looking at this, not been a lot, has it? They've not really probed too deep. I don't think. Sometimes they can make this quite tricky. Even the graph questions. I don't think there's been there's not a snowman. The snowman question was a bit tricky. There's not been anything particularly awful. If anything, this was a wee bit complicated thinking about something in 3D, but again, breaking it down, it was just Pythagoras. Yeah, well, 2016 we're a lucky generation for National 5 Maths. Alright, so final question, crazy. The diagram below shows a rectangle and a triangle. Okay, all measurements are in centimetres. Okay, find an expression for the area of the triangle. Alright, okay, area of the triangle. So what is the area, rectangle, what is the area of a rectangle? Well, an area of a rectangle, as you should know, is just the length times the breadth, okay? So this length times this length is going to give you an area, okay? So in this case, we should be doing 2x plus 1, x plus 8. It doesn't ask us to simplify it any, okay? So you don't have to simplify it. Yeah, it's for 1 mark. You could just leave that, okay? Let's just leave it just now. We might work it out later on. That would be okay just to leave that. Alright. Given that the area of the rectangle is equal to the area of the triangle, show that this is true. Okay. So now what we need to do is work out an expression for the triangle, don't we? So what is the area of a triangle? Well, a half base times the height is your standard equation for a triangle, any triangle. And you think about what that is, half base times height. You're doing base times height to give the area of a rectangle, and then you're halving it, okay, just to give you the area that you want, okay, the area of a triangle, okay. That works for any triangle. But you've got to make sure that your base is this length and the height is the perpendicular height. Okay, that's where people go wrong. Okay, it's got to be two perpendicular values for that equation to work. But yeah, half base times height, and that's why they've shown us that would be in there. Okay, so our base is this and our height is this. So I'm just going to, just because of the space, I'm just going to say that's the rectangle. I'm just going to put it in here for the triangle. Okay, so it's going to be a half times the base times the height, which is a half times 2x plus 5, 3x. Okay. I'm just going to rub them out because they are now just annoying me. Okay, so that's got two expressions. Now it's saying the area of the rectangle is equal to the area of the triangle. So what we're then going to do is put is equal to each other, aren't we? So we're going to say that 2x plus 1, x plus 8 is equal to a half times 2 times x plus 5. So I shouldn't have done that. That's going to again be silly. Sorry, it's getting late. It's getting late. Times 3x. Okay. And we're going to prove that. So let's start multiplying things out. Okay, so I'll do the left hand side first. So I've shown people before, I like this little table where I do 2x plus 1 and do x plus 8. People like to do FOIL, but I quite visually like to just see like this. Okay, so that's 2x squared, that's x, that's 16x, and that's 8. And then I'm going to add my 2x terms together. Okay, so that's going to give me 2x squared plus 17x plus 8. Okay, now onto the other side. Well, half times 2 is very straightforward, isn't it? That's just 1. So then I'm left with x plus 5 times 3x. And maybe I'll just show the working of just cancelling them out. Okay. I'm just going to check I've not written down too many x's or something. No, that's okay. That's right. So then I'd multiply that out. And that's an easy one to multiply it. That's just 3x squared plus 15x. Okay. And that's still equal to 2x squared plus 17x plus 8. So now we need to get everything onto one side. And because we've got a positive x squared shown here, I suggest we bring everything over to the right. Okay. So I want to bring over 2x squared. So 2x squared on the left is plus 2x squared. So I'm going to take away 2x squared. So that's going to leave me x squared plus 15x is equal to, I'm just going to rub that out now because that's kind of in the way, 17x plus 8. All right. Now I want to move over 17x. So it's plus 17x on the left. So on the right, it's going to be take away 17x. Okay, we're just doing the opposite function to undo it. And like I said before, what we're actually doing here is taking away 17x from both sides. And by doing that, it cancels out on this side and appears on the other side as the opposite sign. Okay, so that's going to cancel out. I should have done it on that line with the mic. Yeah, I'm just going to move that. Sorry, just to keep my working as neat as I can. So minus 17x. So that's going to give me 8 is equal to x squared minus 2x because I've taken 17 away from 15. For net space, I've got plus 8 on there, so I'm going to have to do minus 8. So then that's going to leave me 0 is equal to x squared minus 2x minus 8. Simples. So the marking for that one, what we get, let's see. Not much obvious on that yet. You would get an extra mark for expanding. So this would give you your extra mark. And then this would be your extra mark. Sorry, not extra, but for part 2, you get a mark for expanding the rectangle, for expanding the triangle, and then just for proving, you would get your third mark. Now this is actually a really good question from an answerer's point of view, because it kind of gives you the final line of work and it says prove that, show that. So see, because of that, you've got something to work towards. So if all questions were like that, prove that x is 5, you could be working away, and you get it as your answer, you've probably done it right, So again, when you see questions like that, yes, that's just a wee bit easier. It takes a wee bit of the edge off. They could have said write an expression in its simplest form for the the area of the for that function that describes this or something, and made you work through that. So you're just kind of going into the unknown a wee bit more. But we knew we'll put them equal to each other. We're going to get a quadratic, and then when you get the x squared to begin with here, you think, oh, I'm on the right lines. And minus what was good, minus 8, right? So yeah, that's a nice question. So yeah, that's the end of that paper. That was really short compared to the other ones. This one was a little bit of problem solving, but again, when you break it down, you're just calling on your memory your basic area of shapes. And I think this is the interesting thing to remember. The area of triangle is the perpendicular height with the base. Some people would use this length or this length. They get that confused, all right? It'd be the perpendicular height and base. But yeah, really, it was just rearranging equations again. All right. Up here with the formulae. The one I didn't get a chance to go through question 11 actually, which I thought was quite good. Just remember that. So see this sine cos over tan. Remember, you can think about these things in terms of SOHCAHTOA. All right. Never get a chance to go over this. So sine x is opposite over hypotenuse. Cos x is adjacent over hypotenuse. And tan x is opposite over adjacent, isn't it? So does that make sense? Well, let's think about it. Opposite over hypotenuse divided by adjacent over hypotenuse. Keep, flip, multiply. So let's do keep over h, flip h over a, and multiply. H is cancelled over a, which is tan. Yeah. So that's a way you can think on it as well. You can kind of almost substitute this in for O's and A's and H's and then work through that way. That's a valid way of doing it. I like that method. Again, talked about manipulating. Remember your x square graph. Manipulate that. That's the basis of all these parabolas. Everything else has just got negatives, and okay, if there was a negative in front here, it would have been upside down. So yeah, try and remember that. Think logically. Okay, what is this saying? This is saying that when x is 3, this becomes 0, so y is 0. So that's saying, well, 3 is then the root, and that's the turning point, okay, for that graph. All right. So yeah, just have a wee think of these things. Rational denominators, we times it by root 5 and root 5 to get rid of the root 5. That was fine. Here, yeah, we could have multiplied through everything by 6, but I did the smile and cross method on the left hand side first, and then actually multiplied through effectively by 18 on the right. But yeah, you could have multiplied this by 6, this by 6, this by 6, and that would have got rid of your denominators. Totally fine. Pythagoras in disguise. So when you see right angles in the question, think about Pythagoras. But really, you're just labeling up a diagram. How big is this rectangle? Okay, well this coordinate's 2, this middle one's 5. So from here to here is 3. Must be double that for the width. Okay. So just take your time and do some little sketches. There's plenty of space in your paperwork. Well, that was kind of arguing myself a bit too, which should be fine. Like I said, I think the marking scheme said real and distinct roots, but I think 2 real roots would be sufficient. And again, just thinking about what that means, okay? And we kind of went through that as well. Equation of a straight line, very simple, doesn't get a lot easier than that. Simultaneous equations is basically the same thing. And again, manipulating formulae. So actually you see a lot of this is manipulating formulae. There's some core knowledge about triangles and trig and similar shapes and things, but at the core of all of this, it really is just being comfortable with manipulating formulas. So if that's something you're struggling with, get that sorted out, okay? Set area of a sector, area of a circle times by a ratio, and again showing you where the marks were at, substituting for one formula, which isn't quite given, but like we discussed, it's almost given. It's kind of similar to the area of a cone. Smile on a cross, keep, flip, change, KFC and all that. Discuss some of the fraction rules, and finishing off with vectors. Really straightforward. They sometimes ask for the magnitude, which is just 4 squared plus minus 6 squared, all square root. But this is quite an easy one. We're really just adding the top and the bottom, and if we've got a scalar in front, we apply that to both the top and the bottom. Okay, so 4 minus 6 became 2 minus 3. Straightforward. So yeah, quite a straightforward paper. There's definitely opportunities for rookie mistakes, like not putting into English at the end. In here with the year, not double checking your working. So putting in 20 times 1 plus 40, the answer is 60. Nope, that doesn't make any sense. Let's look at the graph. 60 is way down here. We should be up here somewhere. Okay, so a few lessons like that. And yeah, rational denominator, again, if you've not studied, what does this mean? What does this mean? That question goes up all the time, and it just means times it by, in this case, root 5 over root 5. Dead easy. All right. So we just get comfortable with the kind of questions that they're asking, and you'll realise that it's the same stuff over and over again because your syllabus for this isn't huge, and there's only so many ways you can dress up these questions. Okay, and by not making the rookie mistakes, you'll feel fine. When it comes to a tough question, if you can't do it, but like, it's alright, it's just 2 marks, I'll leave that. But if you're making mistakes all the way through, that will add up. Okay, so practice. All right. And yeah, hope this has been helpful. Hope you enjoyed this. Oh no, after all my chatting, that is absolutely hysterical. I've just noticed I've missed a question out. And make sure you finish the question paper. That would be helpful as well. Oh no, I'm so embarrassed. I can't believe I've done that. Okay, well, I'm going to have to. I've only got a minute left. That is absolutely hysterical. It was me thinking that was a dead easy paper. That was so quick. And I've just yapped on for ages. Oh no, okay, I'll have to do this in the next video. Maybe I listen to you, double check you finished your paper. Look for the end of question paper section. Oh, that's funny. I'm not even going to delete this video because I think that's quite funny. I'm going to leave that in.